Ladies and gentlemen, your attention, if you please. It's my duty to bring to your notice a most curious phenomenon, the details of which will become clear to you in a very few moments. Now, the effect to which I refer is the strange sound of my voice. Now, it may not sound strange to you, because you believe that I am talking to you inside an auditorium. Whereas, in truth, I'm out in the open air. It's a trick achieved by electronically processing my voice. But why should the same voice sound different inside and out? Because outside, there are very few surfaces which will reflect the sound waves back towards me, producing echoes and reverberations. But inside, the very opposite is true. Most rooms have at least 4 walls, a floor, and a ceiling, and all of these are surfaces capable of producing echoes and reverberations. But this is a room which has no echoes, because its reflective surfaces, its floor, its walls, and its ceiling have all been covered with special sound-absorbing plastic foam wedges. This is an anechoic chamber, a dead room. They use it for testing sound equipment like loudspeakers. Because when you're making a really accurate sound test, you want to hear only the sound that comes directly from the loudspeaker. You don't want to hear echoes and reverberations from the reflective surfaces. Now, we've borrowed the anechoic chamber for a demonstration. We're going to try to use sounds to create silence. Across the other side of the chamber, there's an identical loudspeaker, switches, and I'll position myself midway between the 2 loudspeakers. Now, this microphone is the only one operating in the dead room. Through it, you're hearing my voice and anything else that happens here. This control circuit enables me to switch on first one loudspeaker, then the other. Now, listen. Do you hear that quiet patch? Now, the microphone is still working because you're hearing my voice through it, but there is certainly a spot here where the sound almost disappears. Whereas over here, it's comparatively loud. I'll switch off both loudspeakers. Now, I'll try very much the same sort of thing, but this time, I'll start a good deal closer to one of the loudspeakers. Here we are. Switch on. 1, 2. Now, all I'm going to do is walk very slowly towards the other loudspeaker. Very strange. All along the path between the 2 loudspeakers, there appear to be loud, quiet sections, and they seem to be regularly spaced out. Absurd. But this is only one of the strange possibilities that exist as a result of sound being sound waves. In certain circumstances, identical sound sources can produce waves which cancel each other out. Let's try and see how such things come about. This is a clue, something you may have seen, a cup of tea that's picking up vibrations. Notice how the circular ripples seem to be almost standing still, an example of what scientists call standing waves. Here's one way they can come about. If waves are sent down a rope in both directions at once, something slightly unusual occasionally results. This, in fact, is a standing wave. Now, the wave obviously isn't actually standing still, but there are places where there's almost no movement at all, just a sort of swiveling. And if we freeze the picture, we can see that these places are exactly half a wavelength apart. Now, if these were sound waves, the places with no movement would be the quiet patches in the anechoic chamber. But in reality, remember, sounds are compression waves, and this picture represents a standing compression wave. Notice that here there's almost no movement. And no movement here. Once again, the places where there's no movement are like the quiet patches in the dead room. Now, I'm driving along the M4 motorway from London to Bristol, and there's something very strange on the radio. There's nothing wrong with the program, but listen for yourself. Did you hear that? It went quiet. Listen a little bit longer. There, it's got louder again. Now it's been going loud, quiet, loud, on and off for the last couple of minutes or so. The quiet patches come approximately once every 6 seconds. I know that there's nothing wrong with the radio, and I'm sure that the BBC engineers at the transmitter aren't altering the level of the power. So what is happening? Let's check on some details. First of all, the way the radio is behaving, the loud and the quiet patches, sounds remarkably like what happened in the dead room, the room which has no echoes. But I'm driving along the motorway at something approaching 65 miles an hour, so clearly the quiet patches are in this case a good deal further apart. And there's another difference, an important difference. I may be hearing sound from the radio, but the radio itself isn't picking up sound, it's picking up radio signals which it converts into the sound that I can hear. So, though I may appear to be driving through patches of loud and quiet sound, what I'm really doing is driving through patches of strong and weak radio signals. Now, the radio was tuned to BBC Radio 4, and the key to the mystery is this. There are 2 Radio 4 transmitters in the south of England which I can pick up from here. One of them is close to Bristol, the other one much nearer London. 200 kilometres separate them. But they work rather like the loudspeakers in the dead chamber, even though 200 kilometres are between them rather than just a few metres. Radio waves instead of sound waves. Radio transmitters instead of loudspeakers. 200 kilometres rather than just a few metres. The effect, though, is very similar.